Guys, welcome to Real Engineering Mechanics. Here is a question on static force system to be precise. So the question says, under non-uniform and slippery road condition, the four forces shown are exerted on the four-drive wheel of the all-wheel drive vehicle. Determine the resultant of this system and the x and y-intercepts of its line of action. Note that the front and track are equal, that is line AB is equal to CD. So the question is saying this particular line here from A to B is equal to this particular line here from C to D. So the question is now asking us to resolve this particular situation. So in this case, we can actually resolve all these forces into both x and y component. So how do we go about it? So from here, as you can see, let's start from point B. This particular force on point B is going towards, let's say this particular force from point B here is going in just this direction. As you can see, let's say this is our y-axis, this is our x-axis. So as you can see, this one here is going towards your x-axis, and if, as you can see, is heading towards the positive side of x. So that means let's write our force in x direction to be equals to 300 Newton. Then as you can see, this other one here also is also going towards the positive x-axis plus 300 Newton. Now for A and B, we've resolved this. Now to C. So now as you can see, let's say we create a point here on C, in this particular point, in this particular dot here, a point here from C. As you can see, this particular force is heading in this direction. So that means in this case, our x will be going in this direction, our x will be heading in this direction, then our y will be heading in this direction. So this will be the angle it is making. So for this particular side, for this particular spot here, it will be, for our y component, it will be our fy. Let me write it clearly. It will be our fy sine of theta, fy sine of theta for fy. It will be it will be f sine of theta for this particular y-axis, and for your x-axis it will be the f cos of theta. So now for you now to know whether it is positive or negative, as you can see, this is heading towards the positive x-axis, and this is also heading along the positive y-axis. So we'll be having plus, this will be 150 for your x-axis cos of 30 degree plus. So now let's also do the same thing for the force at D. So for the force at D, same thing also for the force at D, same thing also. This particular force will be, the resultant will be coming here. So we'll be having our x in this direction, then our y also in this direction. So that means our x in this direction will be also plus 200 cos of 30 degree. So that means we'll be having our fx, the total, to be equals to the total force that is acting along the x-axis rather will be equals to 903.1 Newton in x direction. Also for our y-axis, don't forget, in this case our y-axis is parallel to this. So that means for point B, let me clear this. For point B, our y-axis is parallel to this, our y-axis is parallel to this, same thing parallel to this. So we'll be having a 0 plus 0. So but for here, don't forget that our y-axis in this case, our y-axis in this case will be the sine of this, plus also going in the positive direction, plus f sine of 30 degree. This your f here is 150 sine of 30 degree, plus same thing for here also, you'll be having one here, while your resultant is also coming in this direction. That means plus 200 sine of 30 degree. So that means our Fy will be equals to 150 sine of 30 degree, that's 75, plus 200 sine of this, that's 100, which is equals to 175 Newton in y direction. So if we want to put this in vector form, that means our F will be equals to 903.1 in I direction plus this 175 J direction. Then you can look for the magnitude of this. So then we know the resultant of this will be equals to 903.1 square plus 175 square, then square root of this. So that means that the resultant of this our force will be equals to 903.1 square plus 175 square root of this. So that means we'll be having 9. We've actually calculated the resultant of this system. So the question now says, and the x and y intercepts of its lines of action. So let's erase this particular thing from our stuff. So now let's bring this particular two forces out. Don't forget, this is positive x and this is also positive y for our force acting along the x-axis. So that means we'll be having our force in this direction, your y in this direction, then your resultant r in this direction. So this will be your Fy, this will be your Fy, this will be your Fx. So now for you now to get the resultant of the system, the x and y intercept of its line of action, don't forget, as this particular force Fy is going along the y-axis, its line of action is also going in this direction, and as this one is going in along the x-axis, its line of action is also going along this direction. So for us to now be able to calculate this, so we have to, let's according to this diagram, let's make this our point G our center, this G our center. So for us to be able to solve this problem, let's find the couple of this particular system, of each force on this particular thing. Let's find the moment, rather the moment. This is not a couple because they are not heading along towards different direction and their magnitude is not the same thing. So this is not a couple. That's a mistake. So let's find the moment about this point, a particular point G. So so let's start with this particular 300 Newton first. So if, don't forget, from the definition, we know from our definition our moment is equals to the product of force and perpendicular distance. So if we say we are going along this x direction for this 300 Newton, so that means we will be going in this our force is acting in this direction, then our distance will be the one of Fy. So that's from here to here will be our distance for this 300 Newton. So that means in this case our moment is heading in this particular direction, which is known as your clockwise movement, and we now are taking moment for clockwise is negative. So that means, let's say we are calculating moment about G. Don't forget our moment is product of force and perpendicular distance. So that means moment about G for the point B, we will be having into bracket 300 times, then this, let's convert this into meter, 0.76. So that means, don't forget, since it is going towards the clockwise direction, we'll be having minus plus. Same thing, let's calculate the one of this other forces. This force acting along here, this is our force here, and this will be the perpendicular distance of this particular force, because if you extend this particular force to this particular point, the perpendicular distance of it is this, as you can see. So that means we will be having, and the direction of this is in opposite direction, which is counterclockwise direction. So that, and we know our counterclockwise direction is positive, plus open bracket, so we'll be having 300 times same thing, the same distance, 0.76 in counterclockwise direction. Now for this particular force acting at this particular point C, so the best thing we can do is we look for the, so let's say we extend this. So now don't forget, since we have we extend this particular force, this will be our resultant, this will be our y component, this will be our x component. So that means in this case the perpendicular distance for this your force acting along the y component will be, for the force acting along the y component will be from this particular point here to this particular point here. So that means we'll be having fg, and don't forget this will be in this direction. So this will be in this direction. So let's say this is for A and B. So let's calculate the one of C, moment of G about point C. So we'll be having, so since we are coming in this direction, so we'll be having 150. Don't forget the y component for here is sine 30. So that means we'll be having 150. That means we'll be having 150 sine of 30 degree. Now the perpendicular distance from here to here, that's 1120. So if you convert it to meter, so that means we'll be having times 1.12 in meter. Now the moment in this is in the counterclockwise direction, so that means this is positive. Also, taking your moment for your x, don't forget if you extend the line of action of this, the perpendicular distance of this will be this. So that's 760. So that will be minus, since your moment is in the counterclockwise direction, minus into bracket 150 cos of 30 degree times your distance, which is 0.76. So that means your moment about G, don't forget this, your moment about this particular point will be 0. So your moment about G of C will be equals to, because this and this will actually cancel each other out, so it will be equals to 150 sine of 30. So that's 150 times sine 30 degree times 1.12. So that means we will be having 84 minus 150 cos 30 times 0.76. So that means we'll be having 98.73. So if you do the math, you'll be having 84 minus 98.73, which is equivalent to minus 14.73 direction. Don't forget, since we are getting negative for this particular moment here, it's actually trying to tell us that it is going in the what? The clockwise direction. So now let's do our movement of point G from D. So let's do the one from D. About the G from D. So that means, don't forget, if you extend this particular force D, this particular force D outside, if you extend this particular force D outside, this will be our y component, this will be our x component. So that means if you are taking the perpendicular distance for this our y component will be this, then the perpendicular distance for this our x component will be this. So taking moment for this our y component will be in this direction. So that means we will be having, don't forget, if our moment is going in this direction, according to our calculation, we know this is the counterclockwise direction, which is positive. So that means our moment about that y-axis, is positive. So that means we will be having the force, which is 200, if we resolve it in y component sine 30 degree, times the perpendicular distance from here to here, which is 1.12 in positive direction. Then also for this our y-axis, it will be 200 minus, don't forget this will be going in this particular direction also. So that means it's also going in positive direction. So that means we'll be having plus. Then this will be 200 cos of 30 degree times, now the distance from here to here is 0.76. 0.76. So that means our moment about d from D is equals to moment of point G about D, it will be equals to that's 243.64 Newton. That means our moment about G will be equals to this plus this 243.64 minus 14.73. So minus 14.73. That means we'll be having 228.9 Newton meter. That's our moment about G. So now here is now what we do. So now let's bring these particular chapters out. So that means if this is our y component, don't forget this will be our fy. So this will be our fy, this will be our fx. So fx, my bad, fx, and this will be the resultant. So that means if we take the moment about this point, don't forget our moment is product of force and perpendicular distance. So that means if we've taken the moment, our moment will be since we've already taken the moment of this particular system, so that means our x-intercepts will be our force. Since we know our moment is product of force and perpendicular distance, it will be our force times the perpendicular distance, and the perpendicular distance of our force acting along the y-axis will be the x-intercept. So that means we can now write our moment should be equal to our force in y direction times the perpendicular distance, which should be our x, because that's where it will be intersecting x. The force will be intersecting x. So that means we know our d about x will be equals to this thing that we get 228.9 all over our force along the y-axis, which is 175 Newton. So divided by 175 Newton, so we'll be having 228.9 divided by 175. So that's 1.308 in meter. So if we convert this to millimeter, so that's equivalent to 1308 millimeter. So now let's go back. So that means if this is our force acting along the y, the perpendicular distance of this force will be our y-intercept. So that means our moment, since our moment about 2 is equals to this, so that means we'll be having our force along this dot the perpendicular distance. That's our dy. So that means our dy is equals to the moment of this particular system, which is 228.9 Newton meter all over the force acting along x-axis, which is 903.1. So that means our y-intercept will be equals to 228.9 divided by 903.1. So that means we'll be having 0.2534 so in meter. So if you convert this to millimeter, that's times 1000. So that will be 253.5 millimeter. So that means here is the solution to this particular problem. Thank you very much, guys. Make sure you subscribe to my YouTube channel and always turn on the notification button. Thank you.